Now there are a number of ways to discover clients on the same network. The easiest is to replicate what a normal device would do to discover another device on the same network. So for example, let's say we have a network here. We have devices A, B, C, and D. They are all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. Now, what device A would do is it will use a protocol called ARP. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So the whole point of this protocol is to aid with the situation where there is a client that needs to communicate with another client. It knows the IP of the other client, but it doesn't know the MAC address of the other client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to a specific MAC address that's known in the whole network, and this is known as the broadcast MAC address. When a packet is set to be sent to the broadcast MAC address, all clients on the same network will receive this packet. So, device A will send a broadcast to all the clients on the network saying, who has 10026? This packet is going to be directed to the broadcast MAC address, and therefore all the clients on the network will receive this packet. So this is an example of an ARP request. Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So the next step, all devices will not do anything, and the only device that will respond is device C sending an ARP response. In this response, device C is going to say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses. And the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. It's as simple as that. It works perfectly and it does its job quickly. So, if we wanted to build a script that will allow us to discover clients on the same network, we can use the ARP protocol and send broadcast requests just like the one that's sent here, but we'll send it for every possible IP address. So we'll send it for 10021, 10022, 10023, 10024, and all the way up to the end of the subnet, which is 1002254. So every time we send this broadcast, if there is a device that has that IP address, it's going to respond to us saying, I have that IP address, my MAC address is this. Otherwise, we won't get a response and we'll know that there is no client at this IP address and we'll try the next IP address. Now let me show you a very simple way of implementing this in this lecture, and then we'll dive deeper into it in the next lectures. Now I've already created a new project called Network Scanner. I showed you how to create a new project before, so I'm not going to do that again. Now we're going to use a module called Scapy, I'm going to include its documentation in the resources of this lecture. And to import this module, according to its documentation, we have to do import as usual and write the name of the module, which is skp. But we have to add skp.all to implement all the functions that we can use with this module. Now this is perfectly correct, and you can use skp now in the code, and all you have to do is skp.all dot the name of the function that you want to use. I don't really like that, so I'm gonna rename skp.all as skp. So every time I need to use something from skp module, and instead of typing skp.all, I'll just have to write skp. Now we're gonna make a function, and we'll call this function scan because it's gonna scan for us. And we're gonna make this function take a variable for an IP address. In this function, we're gonna use a very simple function that's in the skp module. You can use this function as usual by doing skp, followed by the function name, which is called ARP. And all you have to do is give the IP to this function. And that's it. It's really as simple as that. And like I said, this is a very, very simple example for discovering clients on the same network using the ARP protocol. But we'll dive deeper into this in the next lectures. Right now, I just want to give you an overview. So in the main code, all we have to do is just call the function because we just didn't call the function anywhere in our code. So we're just going to do scan and give it the IP that we want to scan. And let's say I want to scan the IP of my router. So in my Linux, if I just do route n, you'll see that my gateway is at 10.0.2.1. So this is the IP of my router. So I'm just going to verify that this IP exists. And as a result, I should get the MAC address, because what we're going to be doing is we're going to be sending a broadcast asking who has 10.0.2.1 in this case. And the router is going to respond to me in this case, giving me its MAC address. So I'm just going to do 10.0.2.1, and that's it. Our code is done. Very, very simple. So I'm already in the directory for my project. So if I do ls, I have my project here, which is called netscanner.py. And I can run this by doing python netscanner.py. I'm going to hit enter. And as you can see, we have the result here. We received one packet, we got one answer, we have the IP address, and we have the MAC address of my access point. Now, this function right here, skp.arpping, also takes IP ranges. And what I mean by a range is a way of specifying multiple IPs in the same line. So if I wanted to scan all the IPs within this subnet, so if I wanted to scan from 10.0.2.1 to 10.0.2.254, instead of typing that multiple times, I can just write over 24. Now this is a common way of specifying the whole subnet in networking, so not only in skp. You'll find this anywhere when you're reading or in any networking program. You can just type over 24 to specify the range from 0 to 254 in the last field here in the IP. So if we just run this like that, it's going to scan the whole network that I'm in, and it's going to return to me all the valid IPs with their MAC addresses, as you can see in here. Now, as shown, we didn't really do much. All we did is we imported the skp module, and then we called a function called ARPPing. We're giving it the IP or the range, and it's doing everything for us. It's sending the broadcasts, it's receiving the responses, it's parsing the responses, and displaying the result for us on screen. So we're really not doing much. But that's okay. In this lecture, I just wanted to show you how ARP works and how to use skp with ARP to discover all clients on the same network. In the next lecture, we're gonna dive deeper and rewrite this function in a more advanced way.